You are going to be finding the missing sides of right triangles. So the way that we're going to do that is you can notice that on each of these example problems, one of your acute angles is labeled, one side is given, and then you're looking for the missing side labeled x. We're going to round answers to the nearest tenth. So based on wherever your angle is, you need to label the sides accordingly. So since 53 degrees is here, the side across from it, this is the opposite side. And then across from the right angle, we know this is the hypotenuse. This side isn't being used, so I need to figure out which trig function uses the opposite and a hypotenuse. Thinking about so, ka, toa, we know that sine of an angle gives us opposite over hypotenuse. So we're going to take the sine of the angle. It's always the sine of an angle. So in this case, the sine of 53 degrees should equal the opposite side, which is x, over the hypotenuse, which is 14.9. So our job is to solve for x. Now the easiest way to think about this is rewrite this so that it's a proportion, and we know our cross products are equal. So 14.9 times the sine of 53 will equal 1 times x, or just x. And so in this situation, we're going to have to use a calculator. So go ahead and pull up your calculator, and you're going to want to make sure that it's a calculator that you can utilize the mode and change it so that it's in degree mode. So right now mine is in radian mode, so I arrow down and over and I hit enter. So you need to make sure to change it to degree mode on your calculator as well. And so what we're going to type in is 14.9 times the sine of 53. So 14.9 times the sine of 53, you can close those parentheses, hit enter, and we get 11.899. We said to round to the nearest tenth, so it should be about 11.9. So x is about 11.9. And then you want to check to make sure that your answer makes sense. If this is the hypotenuse, we're expecting it to be the longest side, so it makes sense that this is 11.9. It's a little bit shorter. Let's do another one. Here we have 28 degrees. So this would be the opposite side. We're not using that side. This side would be your hypotenuse, and this side would be the adjacent. So what trig function uses the adjacent and the hypotenuse? That would be cosine. So we could say that the cosine of 28 degrees equals adjacent over hypotenuse. So 9.5 over x. And again, we want to solve this. So I'm going to treat it like a proportion. This means 1 times 9.5 equals x times the cosine of 28. So in order to solve for x here, we're going to have to divide both sides by the cosine of 28. So the process is a little bit different than what we did on number 1. So x is going to be equivalent to whatever we get when we do 9.5 divided by the cosine of 28. So 9.5 divided by the cosine of 28, and I get about, it looks like 10.8 if we round accordingly. So x is about 10.8 units long. And again, we are expecting that to be larger since it is the hypotenuse. A couple more. Here we have 58 degrees. Directly across from it is the opposite side, and this would be our adjacent side. So we're going to use tangent in this case since it's opposite over adjacent. So the tangent of 58 equals opposite 9 over adjacent x. And again, let's solve for that. So 1 times 9 is 9. That equals the other cross product, right? X times the tangent of 58. So to isolate x, we have to divide by the tangent of 58 on both sides. So x will equal 9 divided by the tangent of 58. And if we type that in our calculator, 9 divided by the tangent of 58, we get about, looks like 5.6. So x is about 5.6. And again, that seems to make sense here. The last type of question is one where you're going to have to do some setting up yourself. It says, in each problem, angle C is a right angle. So we're going to be drawing a triangle based on the information given, and it's not going to be to scale, and that's okay. But we have a right triangle, and it says angle C has to be here. So all of these triangles that you have to draw by yourself, they're going to be triangles A, B, C. And here's the deal. You put A and B wherever you want for the two acute angles, but C has to be the right angle. Now, what's true is that side A is always going to be across from angle A. So if this is angle A, side A is going to be over here. If this is angle B, side B will be across from it. And if this is angle C, side C will be across from that. So notice we label those angles with capital letters and sides with lowercase letters. So in this particular given problem, it says find A, so this is what we're looking for, if C, lowercase c equals 15. So this side is 15 units long. And angle B, so this angle here, is 31 degrees. So we're looking for this side, given this side is 15. So the setup here, I can see based on where this angle is, this side is the adjacent, and this side is the hypotenuse. So we're going to be using cosine here. So the cosine of 31 equals adjacent, A, over the hypotenuse, 15. And we're solving for that A. So cross products are equal. 1 times A is A. That equals the other cross product, 15 times the cosine of 31. So if we use our calculator to do 15 times the cosine of 31, we get 12 point, and if we round that appropriately, you'll get about 12.9. So side A is about 12.9. So the only change here is that you had to set up the triangle first, but if you always keep angle A across from side A, angle B and angle C across from each other, or angle B inside C, angle C inside C, then your setup is good and you'll be able to use what we did at the top.